This video covers an aluminum casting repair of a Yamaha Wave Runner exhaust manifold. Here you can see one of the broken lugs in the engine bay, and half of it is all gone, and you can see the threaded hole underneath where a bolt is inserted which holds the manifold in place. This is the part cleaned of paint. The first thing is preserving the locations of important features. The piece of metal will capture the location and size of the holes in the lugs. Features are anything on a part other than a flat, unfeatured piece of metal. It can be a hole, something projecting out of it. Anything at all that isn't a flat piece of metal is called a feature. This close-up view shows the center prick mark that was left by inserting the correct transfer punch that matched the size of the hole in the lug. You can see the small prick punch right in the center. This allows you to accurately drill in the center of the needed hole later on. Transfer punches are an incredibly useful tool to have in your box. They're sized by 1/16 of an inch all the way from a 1/16 all the way up to a 1/2 inch in size, and they're made to transfer holes accurately from a hole in one part to another part. The plate is then inked with Dykem blue so that the shape of the lugs can be scribed on the metal plate. The Dykem blue also comes in red, so you can choose whichever color you want. Here the exact shape of the existing lugs can be seen. I also indicated the orientation of the template relative to the part, so there's no chance of error later. You always want to mark parts which side goes down and which side is facing the part you're working on. So later on, if someone else is working on it, they can accurately put the template back where it needs to be and not reverse things or put things left, right, left. Choices. At this point, I had to choose which path to take in the repair. The existing stubs could be welded drop by drop to rebuild the form of the lugs, then file out the holes again. Based on the fact that the lugs are very thick, 1 inch thick, attached to a thin casting means welding that will not be easy. I made the choice to avoid that issue entirely by sawing off the lugs to the base metal and fabricate blocks of the same size from new aluminum, and then weld on and later drill new holes. The blocks are the same size as the base metal, so welding the two together would be more predictable in behavior. Here the lugs have been cut back to the same place. I made a jig that bolts to the bolt bosses below the lugs. This gives me two things: a way to securely fix the part in a vise, and when oriented 180 degrees, a way to fixture the replacement parts relative to the part in a way that is trustworthy and does not move. With a part like this, you need some way to securely hold it so it doesn't roll around, or by putting it in a vise somehow, because it's a thin casting, too much pressure in the wrong spot could end up cracking it. So having those bolt bosses on the bottom to make a plate to was really a good find. Here's another view of the lugs and the jig plate. Like I said in the prior slide, the plate, when rotated 180 degrees, actually shows the limit of how far the lugs can project out relative to the space in the engine bay. The plate and the angle tacked to it establish an artificial datum group that allows replacement parts to be securely held in place. When a datum surface is not easily available to refer to, one can often be created. In this case, you can see clearly how datum A is a large plate, datum B is the angle attached to it, And C is actually formed by the edge of the stub left by sawing off each individual lug. So all three together are 90 degrees to each other. Therefore, the blocks are locked in three planes and will not move at all when properly secured. In this view, it can be seen how the datum A plate limits the size of the replacement parts so that when it gets returned, the lugs will not interfere with the existing engine. It is effectively a border. It fits very tightly, keeping the blocks in place, restricting them in three planes, X, Y, and Z, which means they cannot move while working on it. The parts are grooved all the way around to allow penetration into the joint. In addition, the part was preheated to reduce the chances of cracking from expansion differences due to temperatures. The weld was done with alternating current at 210 amps. The weld is better than expected with some black discoloration due to impurities in the casting. The metal was thoroughly cleaned with Scotch-Brite and acetone prior to preheating to 300 degrees, which was checked with an infrared thermometer. During welding, the ground was kept as close to the welding area and in line with the weld. This is done to have the most stable ground and also prevent any current from passing through the adjacent surfaces that might arc across and weld together. This must always be considered when working on existing structures. Any electrical systems must be considered as well and keep the current from flowing through them. In the picture, the red X shows a mating surface right next to where the area is to be welded. The green shows the direction of the current through the lugs to the ground clamp, well away from that mating surface. The finished lugs are painted with Dykem blue, and the holes marked in the very first step are brought back and transferred to the new material. This will then be step drilled, starting with a small drill and progressively drilled in 1/16th increments to the required diameter. This prevents stresses that might crack the part or cause the drill to drift out of round. Here, blue painter's tape is used to make a mold for a layer of epoxy on the bottom that will then be used to conform the bottom of the part exactly to the mating surface on the engine block. With the tape removed, the layer can easily be seen. Epoxy does not stick to the blue tape, so it can often be used to mold out small cracks or broken areas on metal quite successfully. The template has had a piece of MDF, medium density fiberboard, glued to it to thicken it and allow it to accurately transfer the hole pattern to the lugs with transfer punches. Here you can see the finished lugs with holes drilled ready for mounting. Additionally, the lugs have been filed in order to allow the lugs to fit the space allowed in the existing engine bay. If you go back to the first slide, you can see the shape that's required to fit that very, very tight space. Here in the final slide, you can see the repaired housing reinstalled inside the engine compartment. And as you see, it's an extremely tight fit and there's not a lot of room in there. So the lugs have to be carefully filed to fit exactly in the space allowed, almost like a key in a lock or a puzzle part in a space.